And y'all, today we're going to learn about an application of exponential functions. This is called exponential growth, and this is just an introduction. It's going to be a little wordy, but just hang in there. Okay, number one, Shane's mom and dad have two proposals for him regarding his allowance. His mom says she would give him $1 the first day, $2 the second day, $3 the third day, and so on, increasing it by $1 every day for a week. His dad says he would give him 30 cents the first day, 60 cents the next day, doubling it every day for a week. Which deal is the better one? Use a chart to clarify. So think about it for a moment before you go on to the next slide, before you move on with the video. So stop the video and think about which deal you would take. If you make a chart with comparing the allowance from mom with the allowance from dad, on day one, mom gives you $1, dad only gives you 30 cents, or 0.3 of a dollar. Day two, mom gives you $2, dad gives you 60 cents, and so on. So if you look at this for a week, so the allowance from mom is increasing by 1 every day. The allowance for dad is doubling. So think of which one is more powerful, increasing by 1 or doubling. At the end of the week, if you add up the allowance for every day, dad wins. So you should take dad's proposal. So this chart is just a copy of the previous chart you just saw, so you don't have to copy this again. But mathematically speaking here, both of these situations can be represented by functions, and that really helps you analyze the situation better. So from mom, you start out with $1, and every day you increase by $1. So remember, this is what's called an arithmetic sequence, and your common difference here is 1. So you start with 1, and then you keep adding 1. And how many times was 1 added here? Well, if you think about it from, there's ones, and again, twice, 3 times, 4 times, 5 times, 6 times. So in 7 days, 1 was added 6 times. Okay, so that's 1 less than 7. Keep that in mind. So from mom, you start with $1. That's what that's for. That's what this stands for, this first. And then you keep adding 1 over and over and over again, n minus 1 times. So after n days, this is how much money you have. And after you simplify it, this becomes 1 plus, distribute that 1, you get 1n. 1 times -1 is -1. But these equal to 0, 1 minus 1. So your final equation is y equal to n. Okay? So in mom's case, mom's allowance was increasing by 1, and that yielded a linear equation. Now from dad, you start with 0.3 and you're doubling 6 times, right? So you start with 0.3 and you doubling, remember, is the same thing as multiplying 2. So you keep multiplying 2 n minus 1 times. So after n days, that's how much money you have. And this is called a geometric sequence, okay, because you're multiplying by a constant instead of adding. So if you're adding by a constant, that's arithmetic. If you're multiplying, that's geometric. And also notice that the geometric sequence gives birth to an exponential equation. Okay, so adding by a constant yields a linear equation, y equal to mx plus b. But on the other hand, multiplying by a constant yields an exponential equation. Okay. And a cannot be 0 because otherwise y equal to 0, and b has to be bigger than 0. B cannot be negative. And let's look at a couple of situations here. So you have number 3, which real world situation is linear, which is exponential? So you need to be able to tell the difference so you know which formula to use. Okay. A savings account which accumulates no interest, but in which $800 is deposited every month. So the first month you have 800, then you add another 800 the next month, and then you add another 800 the next month, and you keep adding. Okay. So remember, if you're adding, what you're dealing with is a linear equation. Okay. So now part B, the value of a house increases by 1.5% each year. So what that means is that whatever the house is worth now, next year is going to be 1.5% times what it was worth. And then the year after that, 1.5% times what it was worth the previous year. So here you're multiplying, so this is going to be an exponential equation. Okay, so as long as you remember those things and keep them separate, if you keep adding the same amount, it's arithmetic sequence, it's a linear equation. If you're multiplying the same amount, it's an exponential equation or a geometric sequence, depending which one you're talking about. The temperature increases by 2 degrees every hour. So is that an addition problem or is that a multiplication problem? So if it's increasing by 2, then you keep adding 2, which means it's going to be linear because the constant amount is added. Every day, a third of a rodent population dies. So that means that you keep multiplying by a third over and over again, which makes this an exponential situation. That's it. Good day. It was a short one.